Hello, this is Dr. Mears, and today I'm going to be teaching correlation and the regression line. This data is on running a mile. As you see, we have age in years and time in minutes. The ages, just review, we have 9, 12, 13, 15, 16, 19, 21, 29, and 32. This should be exactly the same that you have on your worksheet as well. The time in minutes, 8.5, 7.8, 8.2, and so on. So what we've been doing in class is first we are sketching a scatter plot on our paper. So we take out our trusty calculator, our TI-84 here, and we take out our notes for graphing, and we're going to be sketching a graph. When we sketch a graph, what we do is put the two axes down. We need to put a title. Let's title it Running Man. Good movie. And we're going to put the labels. The age in years is going to be our X, which up here we can write down this was our X, which means we put the data in L1. This was our Y, which means we put the data in L2. The reason why this is L1 is because we need age to be input so that we can come out with a time in minutes for running the mile. So back to our little sketch of our graph, age and time, minutes, and our age, I believe, was in years. I always like to put down the units. And when we graph it, it's going to come out to look something like this. Now, it's not going to be perfect because, again, we're just sketching it, but we just want to see the overall trend. Let's see, and this one was here, and that one was about here. So we can see an overall trend here of a negative correlation. Looks about moderately strong. We're going to find out. And so the next part, just as I'm doing, you would analyze it. So we would write down that our data, the data on, and now it's always on time, the data, let's put the data of time in minutes on age in years shows a moderately strong negative linear correlation. Now, we didn't have to put linear because we do have the word correlation as we were looking. We could have put association because correlation we are going to be checking to see how moderately strong it actually is and if we're right with saying that it's negative. However, it's negative because as the age increases in years, the time decreases. So that's what we're going to actually write for our context. The age in years increases as time in minutes decreases for the person, let's just put for running the mile. Also, any outliers, doesn't really look like we have any outliers. We're going to be fitting a line to the data. So if we're looking, maybe if we have a line here, maybe that might be one. But I don't see any apparent outliers. So you would also add that in, no apparent outliers. Okay, so let's go back and let's actually figure out the correlation coefficient, which is our R. And again, you have the sheet that tells you how to do a lin-reg. And when you take that sheet out and you get the lin-reg, you're going to come out with an R of negative 0.78. Now this negative proves that it does have a negative association. And 7.8, since this number is close to negative 1, it says it does have a moderately strong negative association. So since our R of negative 0.78 is close to negative 1, we proved our data of time on age has a moderately strong negative correlation. So here's what it looks like. Now, I didn't say linear because correlation takes care of that. Correlation is your test for linearity. So you're going to see that it is going to be, correlation is linear, it's close to -1, and our information showed a definite decrease in time as age increases in years. Now, the next thing that I want to do is I want to actually fit a line to my data. And I'm not going to draw one in because that would just be my best fit line. I actually want to fit the best line possible. So what we're going to do is we're going to take our data, and when you ran that linear regression, you also received an A value, a B value, an R squared value, and an R value. Our R value, remember, was -0.78. So if you go back and you look at your numbers, this is what you're going to get. I'm going to round to the second decimal, 8.78. And so what we're going to be looking at is A and B. We're going to make a regression equation. What a regression equation helps us do is to predict other data points. So if we have somebody's age, we can input that age and we can predict how long it will take them to run the mile. So that should be interesting. So here we have our y equals ax plus b, and that's the linear reg 4 that you will do on your calculator. And so when we input the slope, -0.11, because this is the slope, and the slope is a, times x, our b, which is our y-intercept, is positive 8.78. If it was negative, this would be a minus. So that's our equation. Let's make it a little bit more professional. Let's say actually what the variables mean. So y is time. So we're going to be able to predict time based upon this slope, -11, times your age in years. So this is multiplication plus our y-intercept, 8.78. So I'm going to be able to predict. Going back to look at our data, we don't have all the ages. We go 9, 12, 13, 15, 16. So we can predict for any age. Let's see, is 18 in there? So 18 would be someplace about here. So let's make a prediction using our equation for someone who's 18 years old. How long will it take, based upon our line, which is this right here, how long will it take them in prediction to actually run the mile? So I have an age of 18, age equals 18. I now have a number. I'm going to take my 18 and input it in for age. So -0.11 times 18 plus 8.78. So now I'm going just to calculate it. Time equals, in my calculator, -0.11 times 18 plus 8.78. And I get a time of 6.8 minutes. So if you're 18 years old, based upon this regression line right here, it's going to take you 6.8 minutes. Now there's a couple other things that we're going to be able to do, and that's to tell what the rate of change is and what the y-intercept is. So in order to describe those, we write sentences. So let's write our sentence for slope, which was our A, and our slope equaled, our A equals -0.11. Our sentence would look something like this. The time will decrease, and now I'm using the word decrease because I have that negative, that means decrease, by 0.11 minutes for every 1 year in age increase. And here again, you see that negative correlation. My y is decreasing by this amount, 0.11 minutes, for every 1 increasing in my x, which is my year of age. So that's how you write slope. And lastly, how you write y-intercept. Y-intercept is going to be our b, and our b is 8.78. And what that means in context is a person will run the mile in 8.78 minutes when they are 0 years old. Now let's think about that. When you're 0 years old, that means that you're not born yet. You're just not there yet. So I'm not going to assume that you're going to be running an 8.78 minute mile when you're 0 years old. So sometimes our y-intercept may not logically make sense. What this is really saying is that our line, going back to our line of prediction, our regression line, will intersect the y-axis at 8.78. So 8.78, so our line starts at 8.78 and then continues to decrease. So that's its starting point on that y-axis. So even though it doesn't make sense in terms of real life, it really tells us that that's where our line will be intersecting our y-axis. I hope this helped. Again, this was correlation in the regression line. Please come and ask if you have any questions. This is Dr. Mears. Thank you.